All right, so we're doing some grade 8 revision. The stuff we're going to do now, you can expect to see it in your test. Okay, so first things first, what are complementary angles and what are supplementary angles? Sorry, I left out something here. Complementary. Okay, so what are complementary angles? What are supplementary angles? So complementary angles add up to what? Or maybe let's start with supplementary. What do supplementary angles add up to?
180.
Perfect. Then complementary angles add up to 90. Yeah, okay. So with supplementary angles, you can identify these in either a triangle, because we know that the interior angles of a triangle add up to 180. What else? Angles on a straight line, okay? So if you had X and Y, these two added together would give you 180. So what else? We learned about parallel lines, right? Okay, so let's say you had two parallel lines like that. Which angles would be supplementary on parallel lines?
The transversal.
Okay, so transverse.
The parallel lines or the supplementary.
Okay, so the co-interior like that.
Oh yeah.
Okay, so the co-interior angles, okay, in between two parallel lines, okay, those are also supplementary. If we add them together, they should give us 180, okay. Now, what's an exterior angle of a triangle? So let's say I sketch a triangle like that, okay? And I've created a straight line, okay? If this was triangle ABC and I extended the line AC to the point D, okay? It's a straight line, so this is an exterior angle, okay? That exterior angle would be equal to A plus B, okay? So if this is X here, X would be equal to A, the angle A, plus the angle B, okay? That's the exterior angle of a triangle. Now, if you were to get a triangle that looks something like this, okay? It's a triangle, okay? And then they suddenly just pop a line above it like that. Would you have any exterior angles there? Would this here be considered as an exterior angle?
No.
No, right? Why not?
Because it doesn't extend straight from the triangle.
Right, well done. Okay, so it has to be a straight line, okay, extending directly. So from AB, let's say, and this would be D here. Okay, that's your angle C. It has to be a straight line like that. Okay, now let's look at these two equations here. So the first one, this 2x is equal to 2x. They want us to solve for x. Let's see. What could the value of x be here? What do you guys think? Can we put any value of x there? It would work. So if we were to take 1 and substitute it in here, okay, it would be 2 times 1, and you'd substitute exactly the same thing on the other side. So 2 times 1 would equal to 2 times 1, which is equal to 2. So both sides would be equal. If I were to take, let's say, 100 and sub in 100 on either side, okay, would either side of the equation still be the same? Yeah, it would, because it would now be 2 times 100, 2 times 100, both sides are equal to 200. What if I put a negative value in there? Okay, let's change it and make it negative 100. So either side now becomes negative 200. Okay, what I'm noticing is that if I substitute in any x value, I see that it's going to work. So for this first equation, we're going to call the solution is basically x is an element of real numbers. X can be any real number. Okay, that's what this means. Okay, you don't have to worry too much about that. I was just giving you an example where you can have infinitely many x values being a solution. Okay, now let's think about this other side. Try and solve this equation. Okay, if you solve this equation by using your balancing method, right? This side you had plus x, so minus x here, minus x there. What are you left with? You're left with 10 is equal to negative 7. Is that true? Can 10 ever be equal to negative 7? No, right? So 10 can never be, yeah, so 10 can never be equal to 7. So your solution here would be, or your answer would be, there is no solution for x, okay? All right, now simplifying. Let's go on to simplifying. Let's look at the first question. We have 25 divided by 5x. Okay. Now for this question, always begin by looking at your coefficients or looking at the numerator, denominator, and see, is there anything in common that I can factor out or cancel out? Okay, so 25 divided by 5, what would that leave us with?
5.
5, okay, so 5 at the top. Now this x at the bottom can't cancel out with anything else, so you're going to leave the x in the denominator. It's not going to suddenly come up and become 5x. Leave the x in the denominator. Okay, leave the x in the denominator. Okay, very important. Now let's look at B. We want to simplify now. For B, what we have here is an example of distribution. Now, when you have this negative sign on the outside, we have to distribute it into the bracket. So there's an invisible one here, okay? And I'm going to distribute it into the brackets. When I do that, I get negative 7 and negative x plus 15. Okay, so what did I do? I distributed the negative 1 into the first term and the second term, which were inside the brackets. Now, when you're at this point, do you have any like terms? Can you simplify further?
Minus 7 and plus 15.
Perfect. So what's minus 7 plus 15? What does that give us?
8.
Okay, awesome.
Minus 8.
Yeah, so 8.
No, 8.
Yeah, like that. 8 minus x. That would be our simplified solution. Now let's look at C. How are we going to tackle these types of questions? Okay, 2 ways to tackle this one. Okay. Any ideas? What should we do? Okay, so let's take this first term here, okay? You can do it 2 ways. Right, let's say I didn't realize that I have like terms in the numerator. If you didn't realize it, that's okay. Okay, we can still work this out. Whenever you get questions like this, begin by splitting them. So you split it, it becomes 4x squared divided by 2x squared and minus 2x squared divided by 2x squared. Okay, so that's our first step. We split it. Okay, once you've split it like this, you're going to look at the numerator, denominator, and see if you have any like terms. So 4 divided by 2, we're going to be left with 2. X squared divided by x squared, we know that anything divided by itself becomes 1. So the x squared divided by x squared becomes 1. So you're just left with 2 there. And then look at this second term here. Negative 2x squared divided by 2x squared. What's your final answer going to be here? The x squared cancels out. Well done, 1. And you have minus 5. Now, what do we do here? There are two ways of working out a question that looks like this. Some people like to write out the x's. If it's x to the power of 3, how many of them are there? There are 3. And then you cancel out and you're just left with 5x. The other way is to say, okay, if I'm dividing bases which are the same, what do we do to their powers? We subtract. So 5x to the power of 3 minus 2, I'm just left with 5x to the power of 1. Right, now looking at this here, do you have any like terms there?
The 2 and the 1.
Perfect. So 2 minus 1, you're left with 1 there, minus 5x. That's your answer. Okay. Some people, okay, if you've got a quick eye, you would have noticed that in the numerator here, these are like terms. So what could you have done straight away? You could have just said 4x squared minus 2x squared. That gives you 2x squared. Okay, so you could have gotten to 2x squared straight away, and that would automatically give you 1 when you divide them. Okay. Okay. Right. So that was question C. Let's see what D is. D is another distribution type question. It is 3a to the power of 4 multiplied. Okay, someone's in the waiting room. 3a to the power of 4a squared minus 4a plus 1. What do we do with these types of questions? We're going to distribute the first term into each term inside the brackets. So what do we do when you multiply bases which are the same? Okay, remember this is one of our laws of exponents. It's a to the power of m multiplied by a to the power of n gives me a to the power of m plus n. Right, so 3 multiplied by the invisible 1 here, you're just going to get 3. Then a to the power of what? What's 4 plus 2? So
6.
Well done. Then 3a to the 4 multiplied by negative 4a. Let's start with multiplying the coefficients. So positive 3 multiplied by negative 4. We're going to get
Negative 12.
Well done. And then we're multiplying a to the 4 by a to the 1. So 4 plus 1, that gives us 5. Then 3a to the power of 4 multiplied by 1, that is just 3a to the power of 4. Are there any like terms? No, there are no like terms. So this would just be our final answer here. Okay, so that's the first section done. Okay, we're now going to go on to geometry. Okay, right. Let's look at this first question here. Okay, they want us to find the missing angles. Right, so now we're going to use our fun angles or fuzz angles. Fun or fuzz, that means you have either you have co-interior, you have alternate, and what's the other one? Co-interior, alternate, and corresponding. Okay, so to work out A, look at where A is, and this is 24. What would A be equal to?
A would be 24 because it's vertically opposite angles.
Well done. So 24, you get a mark for that, and then vert up angles. Vert up angles, that's your reason. Okay, then how would I work out what B is? Look at the position of B. You could either do it in relation to A or in relation to the original angle, which was 24. How would we work that out? So if I'm comparing this B here to the original, what do we call those? B would be equal to?
It would be corresponding because, yeah.
Well done. Corresponding angles. Now, angles like that, then you have to state the parallel lines. AB is parallel to CD. Very important. Okay, you have to state your parallel lines. Now, we could have also said B is actually equal to A, right? What would that reason be? It would be alternate angles. So alt angles, AB is parallel to CD. Okay, that's another reason you could have used for B. Okay, so now C. Two ways of working out C as well. What would C be equal to?
It would be 24 because of co-interior angles.
Okay, so you're right. Your reason is right. So it's co-interior angles, angles. Okay, and you state your parallel lines. AB is parallel to CD. Now, the actual calculation now, okay? Co-interior angles, remember we said they were supplementary. So if I were...
Yeah, it would be 156 because you must say 180 minus 24.
Brilliant. 180 minus 24, which gives us, like you said, 156. Okay, so for that co-interior, what else could we have done to actually work out what C is? Look at where C is in relation to the original angle 24. This is a straight line. So if you have a straight line, you could have just said also 180 minus 24, giving you 156. But the reason this time would be angles on STR line. Okay. Awesome. Well done. So that's first one done. Now let's look at this one. Number 2, we want to solve for X. Okay. Now we have two lines here. Okay. And then we have these two angles. What do we call these two angles?
Vertically opposite.
Good. So what do we know about vertically opposite angles? Vertically opposite angles are equal. So that's your starting point. You would then have to say, okay, 3x is equal to 5x minus 20. Why? Okay, so that's your statement. Your reason would be because of vert op angles. Sorry, vert op angles. Okay. Equal. Sorry, that's your reason. Now you can now solve this. Okay, so 3x minus 5x is equal to negative 20 degrees. 3x minus 5x is negative 2x is equal to negative 20. Divide both sides by negative 2. X is therefore equal to 10 degrees. Well done. Okay. Let's look at number 3. Now, something unique about number 3. We have what we call angles round a point here. What do we know about angles round a point? So the point we're talking about is this one. So angles round a point add up to what?
360.
Okay, cool. So that means all I have to then do here is say, okay, 4x plus 2x plus 2x plus 60 equals 360. So just for doing that, you get your mark for your statement. Your reason is angles round a PT. What's the other reason for this one? Or
Angles rounded. Angles rounded.
Yeah. Yes, awesome. Angles in rev. Okay. Now let's group like terms. Okay, 4x plus 2x plus 2x, that gives us 8x. 60 plus 60, that gives us 120 is equal to 360. Okay, balancing method, you had plus 120. If you take it over to the other side, it becomes negative 120. So 360 minus 120, that gives us 240. And it's equal to 8x. Last step, divide both sides by 8. Therefore, x is equal to 30 degrees. Okay, so for a question like this, you would get like 4 marks, 4 marks. Okay. Right, then our last question. Remember earlier we introduced what do we call exterior angles, okay, and a triangle. So we have a triangle here, and we also have a straight line extending from the triangle. So our exterior angle is this one here. Now, what do these lines mean? These lines which are on the triangle. They tell us that those two sides are equal. So since we have two equal sides, what type of a triangle is this?
Isosceles.
Right, so it's an isosceles. What would then A be equal to?
23.
Right, now what's the reason for that? It's,
Angle.
yeah, carry on, sweetheart.
Angles in an isosceles triangle are equal to
Okay,
the two angles at the bottom.
yeah, so the reason is angles up equal sides, like that. Angles up equal sides. So mark for your statement, mark for your reason. Now, so since we've just worked out that this A here is also equal to 23, okay, how would we work out this angle here? Remember earlier we said that the exterior angle of a triangle is equal to the two opposite interior angles. So your statement, this exterior angle is equal to this plus that. So B minus 10, which is your exterior angle, is equal to the two opposite interior angles added together like that. Okay, the reason is exterior angle of triangle. So mark for your reason, mark for your statement. Now let's solve for B. So 23 plus 23, that gives us 46. Okay, B minus 10 degrees here. Last step, plus 10 here and plus 10 there. This then gives us B is equal to 56 degrees. Awesome. I have a word sum for us before we go. My word sum is the following. The length of a triangle. Okay, so I'm going to write it out. The length of a triangle is 5 centimeters more than its width. Okay. If the perimeter is 38 centimeters, calculate its area. Nice. Right, so, oh no, this is meant to be rectangle, not triangle. Did I say rectangle when I was saying it? Okay, so the length of a rectangle is 5 centimeters more than its width. If the perimeter is 38 centimeters, calculate its area. Right, let's draw this rectangle of ours. Okay, what do they tell us? They say that the length is 5 centimeters more than its width. Okay, so let's assign a random or variable to the width or the length. What do you guys want to call the length? What do you guys want to call the width? Okay, choose which one you want to assign a variable to. Any ideas?
X and Y.
Okay, so let's stick with 1. So let's choose X. Which one do you want us to give X? Or which one do you want to make X?
The width.
Okay, so I'm going to let the width equal to X. Okay, so width equals X. Now, what would the length then be equal to? What did they say? They said the length of the rectangle is 5
X
centimeters.
plus 5.
Brilliant, X plus 5. Okay, now, then they said if the perimeter is 38 centimeters, calculate its area. Okay, so first things first, let's set up an equation, okay, using the perimeter. Then we're going to figure out what X is, the length of the width. So how can I do that? So perimeter is equal to what? The formula for perimeter, if it's a rectangle, you just add all the sides together. So side plus side plus side plus side. So the total is 38. Now I'm going to add X plus your X plus 5 plus the X plus the X plus 5. Do we have like terms? Yes, we do. How many X's are there? There are 4 X's. Then 5 plus 5 here, that is 10. Right. Make X the subject of your formula. So 4X equals, you had plus 10. What are you going to do? Balancing method, subtract 10 from either side. So 28 is equal to 4X. Last step, divide both sides by 4. Therefore, X is equal to 7. So I just worked out that my width is 7 is it in centimeters? Yes. What would my length then be equal to? 7 plus 5, which gives us 12 centimeters. I can now, using those dimensions, work out what the area is. Area is equal to length times breadth. So 12 multiplied by 7, what do I get? It is 84. Well done, centimeters squared. Okay. Right, kiddos. That's all for today.